Hey all you brilliant biologists, it's Miss B here to teach you a lesson on monohybrid crosses with Punnett squares. But before we do that, we need a little refresher on some important terms. The mastery of these 7 terms is needed to understand monohybrid crosses. First, allele. An allele is a variant form of a gene, meaning that there are normally 2 or more forms of a gene that can be expressed. This is one way that people look different. The second set of terms is dominant and recessive. Dominant is a gene that will match the recessive gene when the dominant allele is present. For example, with Mendel's pea plants, tall stems are dominant to short stems, and then wrinkled seeds are recessive to round seeds. The recessive gene will only be shown if it is homozygous, which brings us to the next set of terms. Homozygous means that there are 2 of the same alleles. For example, little t means that it is homozygous for the recessive trait for the short pea stems. Heterozygous means that there are 2 different alleles, like big R, little r, for the dominant trait of round pea seeds. Next, we have genotype and phenotype. Genotype is the makeup of the alleles. For example, big T is 2 dominant alleles for tall stems. Big T is 1 dominant allele for tall and 1 recessive allele for short. And so that brings us to phenotype. The phenotype is the physical characteristic of the genotype. The phenotype for a pea plant with big T and big R is tall stems and round seeds. The phenotype for a pea plant with little t and big R is short stems and round seeds. So now that we have refreshed on our important terms, we can begin to perform our monohybrid crosses on Punnett squares. To start out, we need to draw 4 Punnett squares. We're going to do 4 crosses, 2 for the stems and then 2 for the seeds. For our first one, we are going to do a parent homozygous for tall stems and then a parent heterozygous for tall stems. When we cross this, we get 2 offspring big T, homozygous for tall stems, and 2 big T, heterozygous for tall stems. The ratio for this one is 2 to 2, with all 4 being tall. For the next cross, we will have both parents being heterozygous for tall stems. One of the offsprings will be homozygous for tall stems, 2 will be heterozygous for tall stems, and then 1 will be homozygous for short stems. The ratio here is 1 to 2 to 1, and the phenotypes are 3 with tall stems and then 1 with short stems. Okay, so now we are going to be doing seeds. For the first one parent is going to be homozygous for round seeds and 1 homozygous for wrinkled seeds. The offspring here will all be heterozygous for round seeds. The ratio here is 1 since they're all the same and the phenotype is all round seeds. And for our last cross, 1 parent is going to be heterozygous for round seeds and then 1 is going to be homozygous for wrinkled seeds. 2 of the offspring are going to be heterozygous for round seeds and then 2 are going to be homozygous for wrinkled seeds. Here, our ratio is 2 to 2, with 2 being round seeded and 2 being wrinkle seeded, is the phenotype. If you can do these 4 crosses, you will be an expert geneticist. And that is all I have for you today. Thank you and have a scientastic day.